Okay, section 4.7, this is going to bring our quadratic chapter, chapter 4, to a close here today. We're not looking at another strategy for how to solve quadratic equations. I think we finished that up yesterday with the quadratic formula, and what we're going to look at here today, it piggybacks a little bit off of the completing the square technique, but we're going to look at rearranging quadratic equations from standard form into vertex form, and then we're also going to look at transformations. And I'd actually like to start with the transformation. So I'm going to flip to the very end of this notes page, example 6, because this should be something that at this point should be relatively easy for you. We had studied transformations back in, I think it was section 2.7. If you recall, that's when we were talking about how things that happen on the outside of a parent function affect the graph vertically, but then when you go on the inside of the equation there, now you're affecting the graph horizontally, and if you remember, those horizontal movements are not what you typically would expect. Okay, and so just because this chapter is focusing on quadratic equations, our parent equation would be x squared. And then you can see down here in these 3 examples, we've inserted various numbers, and all we want to do is simply describe the transformation from this parent parabola to the new location that these parabolas are at. Okay. If you recall when we talked about this, I said what I like to do is I like to identify all of the transformations occurring on the outside first, because I know those are all vertical, and the vertical transformations are the ones that make sense. So for instance, this 3 is clearly on the outside of the parentheses. We are multiplying by a 3. 3 is a number bigger than 1, so that is going to be a vertical stretch, and the stretch factor is simply going to be 3. The other thing that I see happening on the outside of this is a -7. So I'm going to call that going down 7 units. Okay, now I'm going to tackle on the inside. The inside, it looks like I'm adding a 2. Remember, we got to slow down a little bit when we describe these. It is not going to go to the right 2. Instead, it is actually going left 2 units. Okay. All right, let's go ahead and try example B. It might be a little deceiving here, but there are actually 3 transformations happening on the outside. This +1, this 5, and the fact that the 5 is negative has to do with a flip or a reflection. You almost want to visualize it like this. You've got both a -1 and a 5 that are both on the outside of this parent function. So I'm going to call the -1 on the outside a reflection, or you could say a flip, over the x-axis. The 5 would be a vertical stretch. The stretch factor is 5. Okay, stretch and shrink factors are never negative. If that number's negative, that indicates a reflection. Okay, and then the +1 is an up 1 unit. There is one thing happening on the inside that is a -6, which I would actually interpret as going to the right 6 units. Okay, here we are again. The number on the outside, a 1/2, happens to be negative, so that would indicate that we again have a flip over the x-axis. Okay, I'm going to treat that now as a positive 1/2, which would be a vertical shrink, or you could call it a vertical compression. The shrink factor is just a 1/2, not a -1/2. The 13 that we're subtracting is going to make this go down 13 units. And then finally, on the inside, the -8 is a shift to the right 8 units. Okay, hopefully that felt like review for you here. Okay, so we're going to flip back to the front of the notes page, and we're going to take a look at, this is what I mean by standard form, okay? Standard form for quadratic equations is ax squared plus bx plus c. Okay, it's often how your I guess I should put like a y equals or an f of x equals in front of that. But it's often how your equations that are given to you as a quadratic equation are represented. Okay, there is a different way that the equation can be arranged, and we call it vertex form. Okay, we call it vertex form. And the advantage of vertex form is hidden directly inside vertex form are the coordinates for the vertex. Okay. In addition to that, A is very visible, and we know that A does tell us whether the parabola is opening up or down. Okay. Now, here's how this works. You'll notice that there is a subtraction sign in front of the H, but then when we report over here that the x-coordinate of the vertex is just h. So you're going to take whatever number is in the parentheses with the x, and you're going to flip the sign or make it the opposite of whatever it is. So if this was a -2, then, Jessie, sorry, this is a -2, then we would report the x-coordinate of the vertex as being a +2. Okay, now the y-coordinate of the vertex is just the same exact number that you see out here on the end. So if this was a -k, like a -8, let's say, then I would keep that as a -8 when I report it as the y-coordinate of the vertex. Okay, so what we're asked to do are three things here. We want to state what the coordinate of the vertex is. We want to state the equation for the axis of symmetry. That's something we haven't done since section 4.1. And then we just simply want to say whether this opens up or down. Right? Okay, so I'm going to grab that number in the parentheses. I'm going to flip it from a -4 to a +4, so that's the opposite. I'm going to grab the number outside, and I'm going to keep that one the same. So the vertex is at the point 4, 8. If you recall, when we talked about the axis of symmetry, we had this formula -b/2a. I don't need you to do that with this, but what we also discussed at the time we talked about that formula is we said the x-coordinate of the vertex is always the exact same value as where the axis of symmetry runs through. So whatever you're saying the x-coordinate of your vertex is, that is also going to be the equation for the axis of symmetry. By the way, very important that when you write the equation for the axis of symmetry that you always include an x equals in front of it. Don't just write down the number 4. A number sitting there by itself doesn't mean anything. The axis of symmetry is always referencing a vertical line, and the way to represent a vertical line is to say x equals and then the number. Okay, and then finally we want to say whether this parabola opens up or down. Okay, when you say whether it opens up or down, you're going to be looking at the a value, whether it's positive or whether it's negative. Okay, if you recall, in vertex form, this number out in front of the parentheses, that is your a. It's a +2, so I'm going to say this opens up. Okay, let's try another one here. Coordinates of the vertex, that's going to be a -6. This is going to be a +2. I'm going to grab the x-coordinate of the vertex. I'm going to use that exact same number, but I'm going to put x equals in front of it, and then I'm going to look at the a value, which is a -3. It's negative, so I'm going to report this opening down. Okay. All right, that was just to get you kind of comfortable with if an equation is already in vertex form, are you comfortable pulling the coordinates of the vertex out of the equation and the axis of symmetry, and then also looking at that a value to tell you whether it's opening up or down. Okay, what we're going to spend our focus on, and this is where completing the square makes a slight appearance, is we want to focus on what if your equation starts out in this standard form, ax squared plus bx plus c, and we want to rearrange it into this vertex form. Okay, what you're going to end up doing when you rearrange an equation from standard form to vertex form is you're going to begin the process of completing the square, but you're not going to follow it all the way through to the end. You're going to stop at a certain point, move everything back to one side, and then your equation is in vertex form. Okay, so I'm going to walk you through this first one here. Okay, what you're going to do to start the problem out is you're going to replace the y with a 0. Okay, in the end, we'll put the y back into the equation, but for right now, replace the y with a 0. Okay, then your next step, think about completing the square. What we do is we always take the c value and we move it over to the other side of the equation. Now, this might feel a little bit weird because I think when we did completing the square, maybe our equal sign was over here on the right side, and so we were moving the c over to the right. Here, it's fine. We're moving the c value over to the left. It's fine. In the end, we're going to be dragging all this back over to the right anyhow. Okay, so this just feels a little flip-flopped here. Okay, then we create a space here for what we're going to be adding. We want a new c value. If you recall, though, we shouldn't create that new c value until we're confident that the a value is a 1. Okay, in this problem here, the a value is a 1. So I'm going to go ahead and off to the side, I'm going to say, all right, here's my b. Then this is my b divided by 2. And this is my b divided by 2 squared. Okay, the b value is this 6 right here. So that's my b. B divided by 2 would be 3. And b divided by 2 squared, that would be 9, okay? It's the 9 that we're going to add to the right and that we're going to add to the left to keep both sides balanced. Okay, then we combine those numbers on the left to be a 14. We say, okay, now this on the right is a perfect square trinomial. Remember what that means. If you were to factor it, it factors into a duplicate factor. There was a shortcut for this. Instead of making an X chart or X puzzle, we went right to that duplicate factor and we said, what you fill in here is the b divided by 2 value. Okay, so I'm going to fill in x plus 3 right there. Now, if we were actually solving this by completing the square, the next step would be to take the square root of both sides and then bring the 3 over. This is the step that if you're just putting this in vertex form, what you're going to do is stop where you're at, bring that 14 back over to the right side of the equation and put the y back in place. Okay, I'm going to go ahead and highlight this. Now this equation is in vertex form. Okay, similar to how these first 3 problems started out. And now that it's in vertex form, we should be able to look at the equation and do the same thing we did up above here. Pull out the coordinates of the vertex. That would be -3, -14. The equation for the axis of symmetry should be the same number as that x coordinate, x equals -3. And then I look for, what is the a value? Well, the a value would be this number out here in front of the parentheses. That's what the a is. It's a positive one. So I'm going to say this opens up. Okay. All right, let's try another one of those. Okay. So my first step is to take the y out. I'm going to replace the y temporarily with a 0, and then I'm going to bring the c value, which is a 3, over to the other side of the equation. Okay. Now, before I fill in the new c value, I need to make sure my a value is a 1. Okay, in this problem, it's not a 1. So I have to force this number in front of the x squared to be a 1. And the way I do that is I factor out a -2. Okay. Remember, when you factor out, what you're doing is you're dividing what's there by what you're factoring out. And so I'm going to divide both of those by a -2, and that makes this a 1x squared minus 4x. Now I'm going to put my little line for my new c value. I want to put a line over here on this side. Okay, so somewhere off to the side, you're going to identify the b value, b divided by 2, and b divided by 2 squared. But be careful. Make sure that the b value that you write down is the b value once you have made the a 1. Okay, it's not from the original problem. It would be this -4. Okay, so we're going to fill in -4 for the b value. Okay, we divide that by 2. That makes b divided by 2 -2. And then we square a -2. We get a +4. So we're going to fill in the +4 here. But do you remember when you factored something out, technically that number that you factored out, you want to distribute that to the number you put on the blank and put those two numbers multiplied together over here on that side. Because if this -2 were redistributed back in, the new number that's technically on the right side is not 4, it would be a -8. And so that's what we need to add on this side. Okay, so continuing on here with this problem, we combine -8 and +3 on the left, we get -5. We keep that -2 out in front. We go to our shortcut here, which is that duplicate factor squared. We look back up and we say, okay, what did we say b divided by 2 was? Oh yeah, b divided by 2 is a -2, so that's what I fill in right here. Okay. Now, this is where you stop. Okay, don't divide both sides by -2, take the square root. That's doing the full-blown complete of the square. If you're just putting this in vertex form, now you're going to swing the 5 back over to the right side, put the y back in place, and then I'm going to highlight this. Here's my equation in vertex form. Okay, I'm going to pull the coordinates of the vertex opposite of the number in the parentheses with the x, so positive 2, and then same as the number on the outside, 2, 5 would be my vertex. Axis of symmetry, x equals 2, and I'm looking at the a value, I see it's negative, so I'm going to say that this is going to open down. Okay. We are not going to do this example, so we're just going to look at these last two. Now, I know that these two problems here are the multiple choice questions, but you have to show some work for how you are arriving at what answer you're circling. Now, I'm okay with us doing a little bit of process of elimination here. Okay, we want these, notice these answers are in vertex form. Okay, so we want to be able to tell which of these equations match up with that graph. And the idea isn't just graph each one and then figure out which one looks like that one per se. We should definitely be able to look at this graph and say, well, first of all, this graph here, it's opening down. And so if it's opening down, we know the a value definitely should be negative. So through process of elimination, we can eliminate C and we can eliminate D, because those both, if you can see that here, I'll just cross it off like this. Those both had a values that were positive. So those are gone. Okay, now I want to take a closer look here. Here's the coordinates of the vertex, 3, 2. Now I know that when those are plugged into vertex form, the x coordinate should be the opposite. So in both of these remaining answers, I would expect negative 3s. And then the y-coordinate should be the same. Those should be positive 2s. Okay, so that part's the same. So we need to try to figure out what is the a value for this. So here's what we need to do. We're going to use those coordinates of the vertex, and we're going to use this extra point that they identified for us. I'm going to go ahead and write down generically how vertex form looks. And then what we're going to do is we're going to plug in, let me change the color on this one here. We're going to plug in the coordinates of the vertex in for the h and the k, and then we're going to plug in the x and the y coordinate of this extra point here in for the x and the y in the equation. And if we make those 4 substitutions for the h, the k, the x, and the y, the only remaining variable would be the a, and we can use algebra to solve backwards for the a, and then we'll know which a is the correct a for our equation. So let's try this. Negative 2 is the y. Negative 1 goes in for the x. I'm going to plug a minus 3 in for the h, that's squared, plus a 2. Okay, so I'm going to bring this 2 over here to this side. That gives me a negative 4 equals a times, looks like I'm squaring a negative 4, which would be a 16. And then I'm going to divide both sides by 16, and that fraction reduces to negative 1/4. So that tells me my answer should be B. Okay, this right here is the work that I need to see to support the answer that you are circling. Okay, so let's try one last one here. This is opening up. Oh man, it looks like all the a values are positive, so I can't eliminate anything there. What about my vertex? The vertex is negative 1, negative 2. Well, if the y-coordinate is negative 2, that one is supposed to stay the same. So I should be seeing negative 2s on the ends, and then I should be seeing the opposite of negative 1. I should see a positive 1 in the parentheses. So I think I could eliminate a and d right off the bat. Okay, so I just need to hone in on what is the true a value for this. Okay, so again, we're going to start generically with vertex form, and then we're going to take the coordinates of the vertex, the h and the k, along with the coordinates of the extra point for x and y, and we're going to plug those in so that a is the only remaining variable. Okay, now, I don't know if you caught all these substitutions here. The formula itself has subtraction here, and because my h was a negative 1, it gives me this double negative, and if you just wanted to go ahead and just say, well, you knew that was going to be a plus when you plug it in, that's fine as well. Okay, so it looks like I'm going to go ahead and add 2 to both sides here. That's going to give me 15 equals a times, it looks like we're squaring a negative 3, which would make that a 9. And then I'm going to divide both sides by the 9. I get a to be 15 ninths. 15 ninths is going to reduce to 5/3. So